Hi guys, I apologize for the video quality right off the bat. I'm trying to do this at my desk, leaning over my Surface Pro propped up to try to get the video in. I just wanted to kind of show you what I was expecting, what we would have done in class if I was teaching the Algebra Tiles activity. Hopefully you have already done the 2 online links, the things that I asked you to do so that you were familiar with the algebra tiles, but I wanted to show you what I was going to do with you. You notice that I have a variety of tiles here. I have my squares, my longs, and my units. Each shape has red on one side and something else on the other. It doesn't matter what the other color is. The red side is negative. So for all of them, red is negative, the other side is positive. When you look at your x square, you're going to define it as an x square because it is literally a square that we're going to say is an x by x square. The sides are the same length, and if I find the area of this shape, I multiply side times side, and x times x is x squared, thus x squared. When I look at this long shape, I can compare it to my x square and see that one side of this shape is x units long. We're going to define the other as being 1. So this shape, this rectangle, is 1 by x. So the area of the rectangle, 1 times x, is just x. So this is an x. We have an x squared and we have an x. Then finally, I have my units. The unit is the width of my x. But if I see and try to line up and see how many units long the x is, you'll see that it does not come out exact. And that was on purpose because I can't say it's a certain number of units long. It's an unknown. That's why I can say it's x units long because I don't know how long it is. Now there are a lot of different ways to use the algebra tiles. We're going to do some very basic polynomial addition and subtraction. When you do polynomial addition, you build both amounts, both polynomial values. So we're going to start by adding 2 polynomials, 3x squared and negative 5x plus 4. There's a trinomial, 3 terms. And to that, I'm going to add 2x minus 6, that binomial. Now, like I just said, with addition, you build both polynomials. So I'm going to build my 3x squared, positive side showing, 5 negative x's, 1, 2, 3, 4, 5, and they're all red because they're negatives, and then 4 units, 4 positive units. So that's the first polynomial, 3x squared, negative 5x plus 4. I want to add to that, so I'm adding on, so I'm building both amounts. I want to add to that 2x, positive 2x, minus 6, which is 6 negative units. Now, if you have done the online manipulatives that I asked you to do, you've talked about 0 pairs and you've worked with 0 pairs. You know that a plus and a minus cancel each other out. They add to 0. They show no value. So let's put together our 0 pairs. Here are 2 0 pairs. That has no value. And then when I look at my units, I can put together 4 0 pairs. That has no value. So there's my 0 pairs. They don't have value. What remains is the value of this sum, of this addition. When I look at it, I see I have 3 positive x squares, I have 3 negative x's, and I have 2 negative units. So that is the sum of these 2 polynomials. Now that is great if you have manipulatives, and your students in your classroom would start out with manipulatives, but you would want them to move toward a pictorial representation. So let's do a pictorial representation. I'm going to be pretty simple and make sure I keep my shapes differentiated. I need colors. I need something for negative and something for positive. For my 3 positive x squares, I'm going to use 3 square-ish shapes. For my 5 negative x's, I'm just going to use a line. I'm not even going to try to turn them into rectangles because I don't want them to start looking like my squares. So there's my positive 3x squares, my negative 5x's, and then I need 4 positive units. I'm going to keep it simple and just do 4 little circles so that it's definitely not the same as my other 2 values, my other 2 units. And then to that I want to add, so I need to also build 2 positive x's and 6 negative units. All right, we are adding, so we built both values. We're going to combine them and look for 0 pairs. Well, I see that I have 2 0 pairs there, so they give no value. And then I have 4 0 pairs here, so they give no value. And I'm left with my 3 positive x squares, my 3 negative x's, and my 2 negative units. That is an excellent, simple pictorial representation, something that I like what I would expect to see on the exam. Now, when you look at the worksheet that I'm going to ask, it asks you to describe the process for modeling addition of polynomials. Build both amounts. That's first. Build both polynomials. Then we combine like terms by finding 0 pairs. And once we've removed those 0 pairs, we look at the value that is left on our mat. That is our process for adding polynomials. Now, when I'm subtracting polynomials, I don't build both amounts. So let's change this. Let's change this problem a little bit and do a subtraction problem. So let's start with 3x squared minus 5x plus 4. And when we do subtraction with algebra tiles, we want to do a takeaway model. We're going to take away from that an x squared, 2 negative x's, and 3 negative units. Now, when I'm doing subtraction, when I'm doing that takeaway model, I want to only build the starting amount. Build only the starting amount or the starting polynomial. And then I'm literally going to take away the second polynomial, those terms. If something shows up that I'm supposed to take away that I don't have on my mat, I'm going to use 0 pairs for missing tiles. Okay, so let's do this subtraction problem. We're starting with 3x squared, negative 5x, and 4 positive units. There is our starting amount. That's all we build. We don't build anything else. Now, my subtraction symbol tells me I'm taking away. I'm taking away a single x squared. So I pick it up and I take it away. I'm taking away 2 negative x's. So I take away 2 negative x's. Now, the next thing I'm told to take away are 3 negative units. I don't have any negative units. I only have positive units. How can I get away with taking away something I don't have? Well, I can add it in by adding in 0 pairs, because anytime I lay down a 0 pair, I don't change the value shown on my mat. How many 0 pairs do I need? Well, I need 3 negative units, so I'm going to need to add on 3 0 pairs. I haven't changed the value shown. I haven't changed it at all, because when I added in what I need, I also added in the opposite, and that's where we get that concept of adding the opposite. This is the best explanation I've ever seen for that. Okay, so now I have what I need. I can take away the negative 3 units, and those opposites are left behind, those opposites that I added in. So I can see the value on my mat is x squared minus 3x plus 6. That's the result of that subtraction problem. Well, what does this look like if I'm not using manipulatives? What does this look like if I need a pictorial representation? Same rules apply. I only build what my starting values are. I'm sorry, I've got to turn this sideways so I can do something resembling a square. 3x squared, negative 5x, and 4 positive units. That's what I'm starting with. I need to take away an x squared, so I'm going to take that away. I need to take away 2 negative x's, so I need to take that away. I don't have 3 negative units. To get those 3 negative units to take away, I need to put in 0 pairs. So I'm going to say, all right, I need 3 negatives. To get those 3 negatives, I have to use the corresponding 3 positives, 0 pairs. Now I can take away the 3 negatives. And the things that are left are the value on my mat. I've got, ooh, look at that. I didn't write that down and nobody was here to catch me. 2x squares. I've got negative 3x. And I've got a total of 6 positive units. All right, guys, now go finish your practice worksheet.